Welcome to Lesson 08 of Debian Mastery, the one where we finally demystify how a name becomes an IP. The premise is simple. SSH prod U01 reads better than SSH 10.01.42, but behind that friendly name sits a configurable chain, etc., hosts, DNS, and a cache. And on modern Debian, etc. resolve.conf is managed by someone. Resolve.conf, systemd resolved, or network manager. By the end, you'll know who owns it on your box, how to configure it properly, and how to run DNS mask for your home lab zones. So let's trace what actually happens when you type SSH prod U01. Your application calls getadrinfo and glebsci consult nsswitch.conf to decide the order. By default, that's at hosts first, then DNS via resolve.conf, which usually hands off to systemd resolved as a stub, which then forwards to an upstream like 1.1.1.1. 5 stops, first match wins, and that hosts. Line you see at the bottom, that's the knob. Files, mdns, then DNS. Change that line, and you change the entire journey. First stop on that journey is etc. hosts, and it's the simplest thing in the stack. A plain text file, 1 line per mapping, no daemon, no cache, no network round trip. You can see the default Debian entries up top, then the home lab fleet, including our friend prod U01 at 10.0.142, and a couple of power moves, pointing a production host name at a local mock during development, and black holing add domains to 0.0 to confirm an entry is actually being consulted. Run githent hosts. It walks NSSwitch the same way your apps do. Just remember, this scales beautifully to 5 entries and painfully past 50. At that point, you graduate to DNS mask. Now we move up the chain to etc. resolve.conf. And here's where most people get burned. On modern Debian, that file is rarely the source of truth anymore. 3 different managers fight for ownership of it. Systemd resolved is the default on most cloud images. Network Manager runs the show on laptops and desktops, and the older resolve.conf package still shows up on plenty of servers. Edit the file directly, and your changes vanish on the next reboot. So the move is run ls etc. resolve.conf. If it's a symlink, it's managed. If it's a real file, check the header comment. Then configure the actual owner and let it regenerate the file for you. On prod U01 and just about any modern cloud image, that owner is systemd resolved. It runs as a local stub on 127.03, caches every lookup, validates DNSSEC, and can even hand different DNS servers to different interfaces. So your work VPN resolves corp names while everything else goes to 1.1.1.1. The pattern is straightforward. Enable the service, symlink resolve.conf to its stub. Set your defaults in etc. systemd resolved.conf, restart, then verify with resolve till status. And when you're chasing a stale record, resolve till flush caches is the switch you reach for. Flushing caches only helps if you can actually see what DNS is returning, and that's where dig earns its keep. It's in the DNS utils package, and unlike ping, it tells you which server answered, how long the query took, and the full record, AMXTXT-NS, the lot. The patterns you'll use daily: dig short for scriptable output, append a record type for specifics, prefix over 1.1.1.1 to bypass your local stub entirely, X for reverse lookups, and trace when you want to watch the resolver walk from root to TLD to authoritative. Once dig confirms prod U01 isn't resolving anywhere, you hit the real question: where should that record actually live? Editing etc. hosts on every fleet machine is fine for 5 entries and miserable for 50. The grown-up answer is DNS mask, a lightweight forwarder, DHCP server, and local zone authority rolled into one binary. Stand it up on one host, bind it to the internal interface only, declare local.dargslan.io as yours so queries never leak outward. Drop your fleet records into a single host file and point every other machine's resolver at it. 50 lines. one source of truth. With DNS mask handling internal names, it's worth tightening the upstream side too. Plain DNS to your provider is still clear text. Every coffee shop and ISP between you and 1.1.1.1 sees that produ01 just looked up debian.org. Systemd resolved fixes this in about 5 lines. Point DNS at Cloudflare using the IPSA hash hostname format so the TLS certificate actually verifies. Set DNS over TLS to yes for fail-close behavior, restart, and confirm with resolve CIL. If you see established connections on TCP 853 instead of 53, you're encrypted. DOH over 443 is the alternative, but DOT is purpose-built and simpler here. Now, encryption doesn't save you from the classic DNS headache. You changed a record at the registrar, and produ01 still resolves to the old IP. That's TTL doing its job. Each record carries a cache me for n seconds value, and every resolver in the chain honors it. Run dig and you'll see the countdown. Here, debian.org has 300 seconds left. The cache stack runs 4 layers deep. Browser, systemed resolved. Your ISP is resolver. And finally, the authoritative server. You can flush the first 2 with resolve ecto flush caches and Chrome's net internals page, but the ISP layer, you can't touch it. Only dig directly at the authoritative name server bypasses it. The real fix is planning. Drop TTL to 62 days before any change, cut over, then raise it back. With the cache problem in your back pocket, let's pull back and look at the 5 gotchas that hit nearly every Debian operator. Number 1 is the classic. You edit, etc. resolve.conf. It works, you reboot, and your name server is gone because something else owns that file. 2. Ping resolves, but curl doesn't, since Go binaries skip nest switch and go straight to DNS. 3 is the stale cache we just covered. 4. 2 resolvers configured. The first one dies, and every lookup hangs 5 seconds waiting to fall back. And 5. Search domains turn SSH Google into Google local dargslan.io. Funny until it isn't. Each one traces back to knowing the chain. So here's what you're walking away with. The 5-stop resolution flow. Etc. hack hosts for those handful of static entries, the 3 competing owners of resolve.conf, and why you configure the active one. Systemed resolved as your modern default with resolved CDL, dig as the detective that bypasses every layer, and TTL as the lever you lower before any planned change. That's lesson 8. Next up is lesson 9, storage. LVM, RAID, file systems, encryption. Your services have IPs from 7, names from 8, and after 9, they'll have durable disks underneath. Stage 2, halfway home. Lesson 8 is done. Resolution flow clear. Resolve.conf manager known. Dig fluent. TTL strategy ready. 4 checkboxes earned. Next time we drop below the network stack and into the disks themselves. LVM expansion, MD-ADM RAID, BRFE snapshots, and ZFS for the storage-heavy hosts. Load up lesson 9 when you're ready. produ01 will be waiting.